We often hear about the lack of diversity in film and television among casts and directors alike, but we don't often consider that this problem exists not only in front of the camera, not only behind the camera, but in many cases inside the camera itself. Let's take a closer look at the biases embedded within the very algorithms that shape our digital world. In 2010, Dylan Fugit, a 20-year-old white man, was arrested for attempted burglary. In 2011, Bernard Parker, a 21-year-old black man, was arrested for resisting arrest without violence. In 2013, they were both arrested again for felony drug possession. The second time around, however, something was different. Information about Fugit and Parker was fed into an algorithm in which Fugit's risk of reoffending was 3 out of 10. Parker's was 10 out of 10, meaning he had a high risk to the community. As time came to tell, this future-predicting algorithm which had favored Fugit was wrong. While Fugit was arrested thrice more, Parker had no subsequent offenses. Now let's shift our focus to the world of image recognition. In 2015, software engineer Jackie Alsnett noticed that Google Photos image recognition algorithms were classifying his black friends as gorillas. Alsnett posted about the incident on Twitter, and Google's chief architect of social, Jonathan Zunger, tweeted that the mislabeling was 100% not okay. Alsnett's frustrated tweets the night of the incident echo exactly this sentiment. He's a software engineer. He instantly diagnoses what has gone wrong. Google Photos, he infers, just did not have nearly as many pictures of black people in it as pictures of white people. Again, I can completely understand how that happens, Alsnett says. Like, if you take a picture of an apple but only red apples, when it sees a green apple, it might think it is a pear. Little things like that. That I understand. But then, your mission is to index the entire world's social knowledge. So how did you, just skip over an entire continent of people? He continues, I couldn't even blame the algorithm. It's not even the algorithm at fault. It did exactly what it was designed to do. Although Google apologized and fixed the issue, 3 years later, Wired reported that the label gorilla was manually deactivated on Google Photos, meaning that nothing will be tagged as a gorilla, including gorillas. But the issue doesn't stop there. The label Faces in the Wild LFW dataset by the University of Massachusetts, used by many modelers, originally contained 13,000 faces and labels scraped from 2007 news articles. Anecdotally, it contained more images of former US President George Bush than the images of black females. So it was not a dataset that represented the diversity of faces found in America, let alone the world. Facial recognition technology was already seeping into everyday life, from photos on Facebook to police scans of mugshots, when Joy Buolamwini noticed a serious glitch.
Algorithmic bias can also lead to exclusionary experiences and discriminatory practices.
Some of the software couldn't detect dark-skinned faces like hers. The MIT researcher Buolamwini found disparities in how facial analysis systems built by IBM, Microsoft, and the Chinese company Face++ classified people by gender. Dark-skinned women were the most misclassified group, with error rates of up to 34.7%. By contrast, the maximum error rate for lighter-skinned males was less than 1%. But the issue of AI biases extends beyond just facial recognition and image classification. Take, for example, the realm of automated vehicles such as Tesla. Research from the Georgia Institute of Technology revealed a disturbing trend. Self-driving cars may be more likely to detect pedestrians with lighter skin tones compared to those with darker skin tones. This disparity stems from the training data used to teach these AI systems. You see, modern AI systems rely heavily on massive datasets of photographs and video footage to learn and make decisions. But here's the catch. If these datasets lack diverse representation, the AI will inherently carry biases. In the case of self-driving cars, if the training data predominantly features pedestrians with lighter skin tones, the AI may struggle to accurately detect individuals with darker skin tones, putting them at greater risk. delving into historical data analysis, we uncover unsettling trends, such as the association of derogatory terms like barbaric and monstrous with Asians, and the troubling correlation between words related to Islam and terrorism. While all these stories may seem shocking, it's important to note that all the AI does is reflect what we put into it, whether it's explicit or inferred. The problem with a system that can, in theory, learn just about anything from a set of examples is that it finds itself at the mercy of the examples from which it's taught. Since algorithmic systems learn from the examples they're fed, if they don't get enough examples of, say, black women during the learning stage, they'll have a harder time recognizing them when deployed. As we conclude our exploration of biases in AI, let us recognize that awareness is the catalyst for change. By interrogating the origins of biases, advocating for diverse representations in datasets, and fostering algorithmic fairness, we can chart a course towards a more equitable and inclusive future, where technology serves as a force for empowerment rather than perpetuation of prejudice.